So today we're going to talk about the programming process, which is very similar to the problem-solving process we talked about a couple days ago. The only difference is that it's more specific to creating a computer program. So let's look at the individual stages that are involved in the programming process. And it's actually very similar to what we saw in the problem-solving process. The first stage is called defining the problem, which, conveniently enough, is the same as the first stage of the problem-solving process. The second stage of the programming process is called planning the solution. This actually includes 3 stages from the problem-solving process: analyzing the causes, developing your plans, and evaluating your solution. Once you've successfully planned what you're going to do, you begin to create your code. This is very similar to implementing the solution from the problem-solving process. Once we've created code, we then need to test it and make sure it works properly. This is the same as the follow-up stage from the problem-solving process. The programming process actually has one additional stage called documenting the program, and this happens throughout the entire design process. So let's look at each one of those stages in a little bit more detail. The first stage, as we saw, was defining the problem. This is where you're going to ask yourself a couple of big questions that incorporate the entire overview of your program. First, what is the purpose of your program? What specifically is your program trying to do? Once you know that, you can start to analyze what input's going to be required in order to do it. What information is your user going to have to give you to make your program function successfully? And obviously, you need to know what output you're going to have to provide. What information are you going to be displaying on the screen so that your computer gets the information that they're looking for? And finally, you need to know what formulas or algorithms you're going to need to use in order to get there. Are you going to be trying to put things in alphabetical order? Are you going to be adding a bunch of numbers together? Are you going to be calculating an average? What formulas are you going to require? You then move to the planning the solution stage. Once you have your big picture decided, you can start to look at the more nitty-gritty details that are going to be required on how you're going to specifically write your code. To do this, you can use one of 2 different design tools. The first is called a flowchart, and this is the method we're going to be focusing on throughout the remainder of this course. A flowchart is a visual representation of the flow of the program. It's going to use symbols to show you what your program is going to be doing at each individual step. The alternative is called pseudocode, and this is the method you'll focus on if you decide to take the grade 11 course. Pseudocode has logic structure. In other words, it shows you step by step what order you're going to go through, but it does not have any command syntax. In other words, it doesn't use any words that are specific to a particular type of programming language. It's all basic, broken, general English. Once you've designed your flowchart or pseudocode showing the order of steps you're going to take, you're going to desk check it. In other words, you're going to read through it yourself in a personal code design walkthrough. Think of this as editing your essay before you submit it, making sure that everything makes sense. After you've personally desk checked it yourself, you may want to pass it off to a peer in order to have them review it, checking again for any errors that might pop up. So how do we create a flowchart? Well, before we can create a flowchart, we need to know what symbols we're going to use to draw it. The first symbol we'll use is an oval. This represents both the starting and the ending of the program. So every program you create is going to have 2 ovals, one at the beginning and one at the end. To show what direction your program is going, you use an arrow. It sort of indicates where you were and where you're going to for the next step. Any calculation or process that your computer is going to perform is in a rectangle. Any information you're going to input from the user or output to the screen is written in a parallelogram. When you're using these 2 symbols, you need to make sure that you're using them very specifically. You need to be very careful the way that you're drawing them, because if you draw something that looks somewhat between a parallelogram and a rectangle and I have to decide which symbol you're going to use, I'm going to assume you're using the wrong one. So make sure you're very clear. The other symbol is a diamond, and this represents a decision. Anytime you have to ask a question where you might do one thing or another based on a particular answer, you use a diamond. So perhaps I'm going to ask what age you are. If you're over 15, you're going to go this way and perform these steps. If you're under 15, you're going to go this way and perform these steps. A circle is used to connect a flowchart from one area to another. Perhaps you have multiple steps that are going to go to the same spot. You might put a circle at the end of each one of those steps with a number 1. Then where it goes, maybe up here, you'd have your circle with a 1 inside showing what happens next. If you've completely filled a page and need to move to the next page, use a flag. This is called an off-page connector. So I put a little 1 at the end of the page. At the beginning of the next page, I'd draw a flag with a 1 at the top showing that that's where I came from. Let's take a look at a specific example of how to create a flowchart. This problem says that we need to input a set of numbers and output the average of all of those values. So the first thing we need, an oval to show the start of the program. After we create an oval, we now need to get our input using a parallelogram. We now have one number, but one number isn't enough to get us an average. So we're going to ask the user how many numbers they're going to have. We don't know how many numbers they're going to enter, so we ask them if they have another one. If they do, they give it to us. Then we ask for another number. And we keep on doing this over and over again until they tell us there is no more numbers. Then we'll follow this pathway where we can now calculate the average because we have a set of numbers to calculate. Once we've calculated our answer, we can output the result and then end our program. Once we've successfully created a plan that we think is going to work, we can code it. We're going to translate that plan into a formal programming language, and there's a variety of languages that exist for us to use. In this course, we're going to be focusing on writing programs in Alice and in Python. After you've created your code, you need to test it. And again, there are two ways to test your program. The first is through a program called a compiler. The compiler is going to take the code that you have written in whatever language you've written it, and it's going to convert it into a language that the computer can understand. For example, in Java, it's going to turn it into binary code, which is a series of zeros and ones. While it's translating from the source code to the binary code, it's going to be checking for errors, specifically called syntax errors. These are errors in the way the code is written. It means that the computer is not going to understand what it's supposed to do. Think of these as things like spelling errors, having an opening quotation and forgetting to put a closing quotation, or improper indentation of your code. Once you've compiled successfully and your computer can run your program, you need to debug it. This is done by running your program over and over again with a variety of different values to ensure you're getting the answers that you expect. This will help you to detect what are called logic errors. A logic error is an error in the way the program works. It still functions, it doesn't crash, it doesn't break, but it doesn't give you your expected values. For example, you might perform the following equation, 2 plus 2, and give you an answer of 2. Since we know that 2 plus 2 obviously doesn't equal 2, we know that there's an error somewhere and we need to go back and fix it. As we said earlier, documenting the program is going to happen throughout the development process. We're going to be generating material during each step. Defining the problem, we're going to create our problem definitions where we analyze what our program is supposed to do. Creating our program plan, we're going to be making our flowchart. While we're creating our code, we're going to write comments in our code to explain to other programmers what our code is supposed to do. While we're testing our program, we're going to be creating testing procedures so that we know that we tested for all possible scenarios. And finally, we're going to be writing help menus and users manuals for the end user so that they know how to use our program. That's it. You now know how to follow the programming process, and we'll see you tomorrow to figure out how we can practice that.